Here we have a vectors question. So I've already set up a small diagram. You never draw these to scale. We're not drawing 3D coordinates or anything clever like that. Just a small diagram to summarize what the question tells me. So A, B, C, D is a parallelogram. So those letters A, B, C, D go around the outside of the parallelogram. And we've been given position vectors. Position vectors are just a vector way of telling you the coordinates of those points A, B, and C. So A has coordinates 1, 7, minus 2, and so on. So I've put A, B, C in the diagram. We don't know D yet. And in fact, the first part of the question is to find the position vector. So find the coordinates in vector form of the point D. So the trick to these questions is thinking about the vectors as journeys. So I need to get to D. So a nice way to get there would be from A to follow that journey up the side of the parallelogram. And I know that that journey will be exactly the same as this journey from B to C. So to start solving part A, first of all we need to understand what is that journey from B to C. Remember, have this sort of, not quite a formula, but we say end minus start. Let's write that at the top, end minus start. So for BC, I need to take the end, which is C, 2, 10, 9, and subtract the start, which is B, 4, 3, 3. And when we do that subtraction, we get the journey from B to C is minus 2, 7, 6. Well, as we said, that journey from B to C is exactly the same as the journey from A to D. So the journey from A to D is also minus 2, 7, 6. So that means if I want to know where D is, I start at position A and I add on that vector journey. So A is the point 1, 7, minus 2. That's my starting point. I want to add on that vector journey, minus 2, 7, 6. And that will tell me where I finish is negative 1, 14, 4. So that must be the position vector of D, or the coordinates of D. So I might add that to the diagram as well. We found minus 1, 14, 4. Just to talk about it, I'll change colour to green for an alternative strategy. You might think that to find out D, you could work relative to C. So there's a journey from C to D across the top of that parallelogram. Well, that journey would be the same as BA. So what you could do, and you might want to try this, is calculate the journey BA using end minus start. And then say, okay, if I want to get to D, then I start at point C and I add on that same journey. And if you try that and you try the numbers, you should get exactly the same position of D as minus 1, 14, 4. Okay, let's scroll on to the next part. Don't read part B directly because there's a bit of information before we get to the question part B. The vector AX has the same direction as AB. The same direction as in vectors it means they're parallel vectors. It means it's just a multiple of, it's a stretch. So AX is a multiple of AB. Let's put a note there, multiple of. And we know AB. We found that out earlier, didn't we? Oh no, we didn't, but we can do that. Given that the magnitude of AX is 10 root 2, find X. Okay, so it sounds like AB is going to be the key to our working here. So let's start with the vector AB. We're doing end minus start. The end is B, 4, 3, 3. The start is A, which is 1, 7, minus 2. And if we do that subtraction, then we get AB is 3, minus 4, 5. Okay, now the next bit of information we were told is about the magnitude of AX. So let's just check what's the magnitude of this vector already. So you have to do Pythagoras on its components, 3 squared, and negative 4 squared, and 5 squared in the calculator, and it turns out that that has a magnitude of 5 root 2, which fits nicely actually. So the question then tells us that AX should have a magnitude 10 root 2. So we want to stretch the vector AB that we just found to make its magnitude become 10 root 2. Well, I think we just need to multiply it by 2, stretch it by a factor of 2. So therefore, AX as a vector will be twice the vector AB. So AX is the vector 6 minus 8, 10. Now we're not quite finished because that's the journey from A to X, and we want to just find out where X is itself. But like we've used a couple of times already, I'll write on the side here. To get to the coordinates of x, we can start at the coordinates of a and add on the journey that gets us from a to x. Now a was 1, 7, minus 2, that's our starting point. Add on the journey that we've just found, which is 6, minus 8, 10. And that sum will tell us the position of x, which is 7, minus 1, 8. And that's what the question was looking for. So it's all about starting points plus journeys to get to a destination.